Hey guys, welcome back. Today is day 62 and today we're going to talk about the properties of radicals. We're going to learn how to multiply, add, and subtract them. So a radical expression is in its simplest form if the following conditions are true. No perfect square factors other than 1 are in the radicand. No fractions are in the radicand, and no radicals appear in the denominator of a fraction. So we're going to be focusing on the second bullet points tomorrow, our next class in day 63. But today we're going to start out just by multiplying the radicals and then simplifying. And we're going to simplify them using the method that we learned in day 61. Okay, so the first thing we do when you multiply is you just multiply the two radicands together. So you're going to take 3 times 18 and you're going to get radical 54. Okay, from here you're going to factor out your perfect square factors, which we can do by prime factorization. So maybe I'll do 9 and 6 to get 54, and 9 I'll do 3 and 3, and 6 I can do 3 and 2. Okay, so when I put it in simplest radical form, I look for my pairs. So because my index is 2, remember it's just the square root. So I've got one pair of 3's, and then what's left over are the 3 and the 2. So we end up with 3 radical 6 as our answer. Okay, so the second one, we multiply again together. We get 150. Okay, I'm going to start on prime factorization. I'll use 15 and 10. Remember, it doesn't matter what you start with. 3 and 5, so they're both primes, so I'm going to circle them. In 10, I have 5 and 2. Okay, so simplest radical form. All right, I look for my pairs. I have a pair of 5's, so that goes outside the radical. And 3 times 2 goes in as the radicand. When I multiply it together, I end up with 5 radical 6. So that would be my final answer. Okay, the next one, radical 4 times radical 25 would just be radical 100. And since 100 is a perfect square, my final answer is just going to be 10. Okay, so number 4, I multiply them together, and I get a radical 25. Again, it's a perfect square, so the square root of 25 is just 5. 3 times 30 is 90. Okay, so I'm going to start factoring it. I've got 9 and 10. 9, I can do 3 and 3. And 10, I can do 5 and 2 for the prime factorization. In simplest radical form, my index is 2, so I look for my pairs. I've got one pair of 3's. What's left over is 5 times 2, which is 10 for the radicand, so 3 radical 10. All right, when we take number 6, we're going to take radical 9 and square it, so we're going to multiply it by itself. Okay, we end up with the square root of 81, which is 9. So notice what happens if you take a square root and square it, you just end up with what you started with. Okay, so you could recognize that and just put down 9. Or even think about it, square root of 9, that's a perfect square. It's 3, and 3 squared is also 9. Okay, a couple of different ways you could have done that one. All right, so if you'd like, you can try the next 3. Maybe pause the video, try them, and then check it. Okay, so I'll go ahead and do them. All right, and again, it doesn't matter the 2 factors you start with. You could have started with 3 and 6. Okay, so in simplest radical form, I look for my pairs. I've got a pair of 3's and then 2. So 3 radical 2 would be my answer. Okay. When I do number 8, I get radical 50. And maybe I'll do 2 times 25. 25 is 5 times 5. So in simplest radical form, I look for my pairs. I've got a pair of 5's with the 2 left over. So 5 radical 2. All right, and then number 9, again, get the same number and you're squaring it. So you're going to get square root of 16, which is just going to be 4. Okay, so now to add or subtract radicals, that's actually very easy. Okay, you're going to think about combining like terms, and you're going to think of the radicand as being the like term. Okay, so the square root of 2 in example number 10 would be the like term, and the coefficients would just be the numbers before the radicand, so the 2 and the 6. So to simplify them, you just combine the coefficients on like radicals. So 2 plus 6 would be 8, and it would be 8 radical 2. So be careful, you're not going to take the radical 2 and add radical 2 and get radical 4. You keep it the same. Okay, if there isn't a coefficient there, it's just like with like terms, there's really a 1, and 1 minus 6 is negative 5. So this would be negative 5 radical 5. 2 minus 5 is a negative 3, so it's negative 3 radical 6. Okay, so this starts out pretty easy. 3 and 9 is 12, so we get 12 radical 7. And then for number 14, we've got radical 12 and radical 27. Well, we can't combine them because they're not like radicants. All right, so what we want to do is put both of these, because they're not in simplest radical form. So we could say 4 times 3 and 2 times 2. So radical 12 can be represented by 2 radical 3. All right, but then 27, we'll do 3 and 9, and we get 3 and 3. So then we're going to subtract. We've got a pair of 3's and radical 3. Okay, so now when we do that, we end up with the same radicand. We've got 2 minus 3 for the coefficient would be a negative 1. So we're not going to write the 1, but we're just going to write this as negative radical 3. Okay, so same with number 15 when we do it. All right, we look at radical 6. That's in simplest radical form, but 24, okay, let's go ahead and do, let's see, 4 and 6, and then 4 we can do 2 and 2, and 6 we could do 3 and 2. Okay, so we've got radical 6, and we're going to subtract, and in this case, we've got a pair of 2's, so 2 radical 3 times 2 is 6. So now at this point, we have the same radicand, so we can look at the coefficients. 1 minus 2 is negative 1, and we end up with negative radical 6. Okay. You might want to pause here and try it from here on your own and then come back, but I'll go ahead. So now we've got like radicands, so 3 plus 4 is 7, so 7 radical 3. 8 minus 2 is 6, so we end up with 6 radical 10. Now the third one, okay, we've got radical 5, radical 8, and radical 18. All right, 5 is already in simplest radical form, but let's look at 8. We've got 4 and 2, 2 and 2. Okay, so we have radical 5 minus, and we have a pair of 2's, 2 radical 2. And now let's look at our 18. So with 18, I'm going to do maybe 9 and 2, and then 3 and 3. Okay, so then I'm going to do plus, we've got a pair of 3's, 3 radical 2. All right, so our final answer would be radical 5, and a negative 2 plus 3 is positive 1, so it's just going to be radical 5 and radical 2. And we would leave it like that. We wouldn't do anything else. We can't combine them. They're not like radicals. Okay, so I hope, well, I forgot, we've got 2 more. Okay, so now we want to look at what value can be placed under the radical symbol to make the statement true. So we're kind of going backwards here. All right, so to go backwards, the first thing I like to note is what's the index. All right, the index is 2 because there's nothing there, so we know it's actually a 2. So that means we're going to take what's outside the radical, okay? So the 5, so what's outside, let's say the coefficient of the, we're going to take the coefficient, which is 5, and we're going to square it, and then we're going to multiply it by what's inside the radical, okay? So it's going to look something like that. All right, so 5 squared is 25. 25 times 5 is 125. So what goes inside of it would be the number 125. We wouldn't want to put the square root around 125. We just want to say, it's saying what value can be placed under the radical symbol. All right, now if it's the index is 3, like in number 20, we're going to take what's on the outside, or the coefficient, the 3x, and we're actually going to cube it. We're going to put it to whatever that index is, and we're going to multiply it by the 5x. Okay, so when we do that, okay, we're going to use our properties of exponents. Our 3 is going to be cubed. Our x is going to be cubed times 5x. Okay, 3 cubed is going to be 27. X cubed times 5x. And 27 times 5 would be 135. And our x would be to the 4th power, because remember, with the property of exponents, when you multiply and you have the same base, you add the exponents. So that's how we get 135 x to the 4th. Okay, so that's it for today, and next class we'll learn how to rationalize the denominator and how to divide radicals. Bye.